material, the exam, and the labs that we offer you in this course. So let's start with the session, and a little bit of brief about myself. My name is Muhammad Usman. I have been working in the IT and telecom industry for the past 10 years now. And more recently, I have started to work in the DevOps area as a freelancer. And I provide consultancy services as well to different organizations when it comes to Kubernetes and the related technologies. So my previous experiences include working in Telenor and Microsoft and Gulf Business Machines, and more recently I'm located in Qatar, and I'm working for a government entity here, and we are doing multiple projects here related to systems infrastructure and a little bit of DevOps as well. So in this session, let me just take it to the full screen. So in this session, we are going to cover the exam introduction, the details of the exam, what are the system requirements and the exam objectives, what are the prerequisites, and we are going to cover a couple of container runtimes, which include Docker and Cryo or CRIO. Since Docker support is now officially deprecated starting from Kubernetes 1.20, but Docker is such essential component when it comes to containers and container orchestration. So we cannot skip Docker in itself, but we are going to cover Docker as well as another container engine, which is actually CRIO, or some people pronounce it as Cryo. So let's start with the session. I have covered the introduction to MRGT. So let's just skip the 3 slides. The CKA exam, the purpose of the CKA exam is actually to provide the administrators the right knowledge in order to administer the Kubernetes environment wherever they are running, whether be it in production or development, and it provides them the skills in order to manage a Kubernetes environment in a proper way. So this is a introduction course, and it covers in details all of the administrative tasks that is expected from a Kubernetes administrator. So this is more oriented towards the systems administrators who have a previous background and knowledge of virtualization domains, and they have been managing Linux systems and somewhat Windows environments as well. So as we all know that the world is transforming from the virtual machines towards a containers environment, and everybody is looking towards a container orchestration engine, and Kubernetes of all the container orchestration engines is the most popular one and is most widely used across the world, as it has offerings and multiple options. So there is an on-prem option available when it comes to deploying Kubernetes in your own data center in the form of Red Hat OpenShift and VMware Tanzu and Google Anthos. And you can also deploy it as a native Kubernetes environment in your on-premises architecture using kubeadm as well. Whereas in the cloud, you have multiple offerings from all of the cloud providers, whether you want to deploy it as virtual machines or you want to use the managed Kubernetes services that are provided by the cloud providers. So there are multiple options and plethora of services related to Kubernetes that are available in the market, whether you want to deploy it in the cloud or you want to have an on-premises environment in your own data center. So this course is not much related to the developer side, but it covers the administrative aspect of a Kubernetes cluster, and we are going to discuss in detail in this course that how an administrator can perform can perform his tasks or manage a Kubernetes cluster in the most efficient way. So from the exam's perspective, there are 5 objectives in this exam as of today. The course has not been revised for 1.20 as of yet. It is still, the course, the objectives are still the objectives are still relevant from 1.19 version of Kubernetes, and it starts from the cluster architecture, installation, and configuration. Then we have, which is a weight of 25%. So everybody has to know how to deploy Kubernetes cluster, its architecture, the installation through kubeadm, and the initial configuration which is required to run a Kubernetes cluster in the proper way. Then we have workloads and scheduling, in which we discuss how we can schedule pods, let's discuss, let's say, containers in the most simplest way right now, because pod is a Kubernetes terminology which we are going to cover in the course. So how we are going to run containers in multiple worker nodes, and how we can customize the scheduling so that we can choose ourselves that which containers we want to run in which worker nodes, or if we want to run them in all of the nodes. So these kind of things we are going to discuss in the workloads and scheduling, and we are going to discuss the basic API objects of Kubernetes, which include pods and replica sets and deployments and services. In the third section, services and networking, we are going to discuss in detail what are the CNI plugins that we can choose as an option to deploy in the Kubernetes environment. The fourth section is related to storage. So everybody has this perception that when it comes to containers, they are only meant to run stateless workloads, but storage and persistent volumes give this leverage to the containers or the pods that we can store, that we can run our stateful applications as well in the Kubernetes environment. And then the troubleshooting part, which is the most important duty of an administrator, that whenever there is an issue, then he needs to know the troubleshooting steps, that how they can find out the root cause of a particular issue and then provide a resolution so that they can keep the cluster and the applications up and running. So it is a very practical course, and the exam itself, tests your knowledge from a very practical perspective. So there are very real life scenarios in the exam that you get in the questions of the exam, like how you can perform an upgrade of a Kubernetes cluster, or how you can troubleshoot a particular issue. So and how you can assign persistent storage to your workload, like for example a database. So these kind of exam questions appear, so they really test your knowledge and skills from a real practical environment perspective, and this really helps you learn the Kubernetes in the most efficient manner, in which you really gain some hands-on knowledge. So the course also is designed in such a way that you get to know all of the hands-on aspects of the Kubernetes cluster. So moving forward, exam details. The exam is actually delivered online, and you can take it from anywhere at the comfort of your home as well, and in your office. So there is no limitation of location. The exam actually consists of 15 to 20 performance-based tasks, but to be exact, the exam actually has 17 questions. Right now, the current version of the exam has 17 questions. It may or may not change. That is up to the CNCF, who actually designed the curriculum of the exam, and they can change at any time as the Kubernetes version changes. So candidates have 2 hours to complete both the CKA and the CCAD exam. The CCAD exam is Certified Kubernetes Application Developer exam. So I have a question as well in the chat, that what is the difference between CKA and CCAD exam. So in the CKA exam, it is more oriented towards system administrators and Linux administrators, and whose duty is actually to keep the cluster up and running and make sure that they provide the infrastructure infrastructure services to the developers, and make sure that your environment is working in the most healthiest manner. For the CCAD exam, there are a couple of I would say there are some more topics that are not covered in the CKA exam, like cron jobs and jobs and liveness probes and readiness probes. So there are some topics which are not covered in the CKA exam, and there are some topics which are related to the administrator, which are not covered in the CCAD exam. So you can go to the cncf.io. Let me show you the website. So if we go to the cncf.io website, there are details of the exam objectives that are covered in both the exams. So let me open these two links so that we can see the difference between the CCAD exam and the CKA exam. So the objectives of the CKA exam, we have already discussed. The objectives of CCAD exam are core concepts. So there is some overlap between these two exams as well. So the core concepts, the configurations, the multi-container pods, some observability is also covered in CKA as well, because they have the similar concepts. There are some other topics which I discussed previously, like the readiness probes and the liveness probes and jobs and cron jobs, which are not covered in the CKA exam. They are covered and tested in the CCAD exam. So there is a bit of bash scripting also involved in the CCAD exam, although it is not related to a pure developer scenario, but you need to know a little bit of bash scripting in the CCAD exam. So from the CCAD exam perspective, it is also 2 hours, and there are 15 to 20 questions to be precise. I believe there are 19 questions in the CCAD exam, and it may change with the passage of time. So I believe I have answered your question. If there is any confusion, you can let me know in the chat, and then I will brief you further. So the exams are proctored remotely via the streaming audio, video, and screen sharing. So you have to share your audio, video, and screen as well to the proctor, and you are going to be monitored during the duration of the exam. And the results will be emailed. At least it will take 36 hours, or it can even take more, in order for the results to be received by the candidate. So the system requirements, you can take it in Windows, Linux, or Mac, whatever operating system you have, and you need to have the Chrome browser, which has to be latest version. A very good and reliable internet access needs to be there. You need to have a working microphone and webcam. The external webcam is not really required if you have a good webcam, which can give you a proper focus, because there is an ID check, and the ID has to be visible to the proctor when he is checking your identification. So if you have an inbuilt webcam which gives you the proper focus, then external webcam is not required. You can also run a system compatibility check of your own system, PC or laptop, wherever you are taking the exam, using the link that I have embedded in this slide. Other than that, you need to have a national ID card or a passport or a license in order to verify your identity. And for more details, I have embedded another link in which there is a complete handbook of the candidate who is trying to appear in the exam. So there are two questions. Are we allowed to use any resources during the exam? Yes, there is one tab which is allowed, in which you can open 3 links which are related to Kubernetes official documentation and GitHub repository, which is actually mentioned in the link that I have embedded. And let me show you on the website as well. So if I exit my screen and come to the CKA exam, so if we check these links, there's a clear mention that you can open one extra tab and you can open these three links. So during the exam, the candidates may use their Chrome browser to open one additional tab in order to access assets at these three websites, not other than these three websites. So even if you open a hyperlink, if let's suppose you have opened this kubernetes.io/docs and there is a hyperlink which leads to a third-party website, you should not click on that because that will violate the exam policy and the proctor may stop your exam. So you have to strictly follow the links which are the subdomains or the sub URLs of these three URLs which they have mentioned here. So you have to be extra careful when you are opening these links during the exam, and only one additional tab is allowed during the exam. So one tab has to be for the exam portal and the other tab on which you can these three links. Okay, so the acceptable environment is that your desk needs to be completely clear of all the accessories that you have present on your desk. So no such objects like paper or pen or any other devices has to be present other than your laptop and the charger. And you can have a mouse as well attached to the laptop, or you can have a wireless mouse as well. So nothing has to be present on the desk, and even in the room you cannot have charts installed on the walls. So they will ask you to remove it. So it is better that you give the exam in a clear environment, or in a small meeting room, or a room like that. So the candidates will definitely be asked to remove any of the items prior to the exam being released. And it is better that you clean the environment yourself so that you can, save yourselves some time and properly focus on the exam itself. Because when the proctor starts to ask you to remove the stuff, then it really distracts you during the exam time. So it is always better that you prepare it, before trying to join the exam session. Okay. So also you need to have proper lighting, and you have to make sure that there is no light right in front of the camera, which gives you inconvenient shadows and not shows your face properly, because the proctor will not release the exam in that case. So there are some technical instructions for root. You can use sudo -i, and in a Kubernetes or a CKA exam, there are at least 7 clusters that you have to continuously switch when it comes to doing your tasks. So task 1 you can do in a you are asked to do in one cluster, and then task 2 you will be asked to do in another cluster. So you may have to even log into the master or the worker node using SSH as well, and then you will have to perform sudo as well in order to perform the upgrade of the node or whatever troubleshooting task that you are asked to perform in the question. So you have to remember that you will be provided with a jump host, and then the jump host will be running kubectl in itself, and it will be configured to use multiple clusters. So it is called context switching in the terms of Kubernetes clusters. So from a single kubectl command line interface, you can run or manage multiple clusters. You just have to use context switching of the Kubernetes cluster. So you have to make sure that you are on the right cluster in order to perform the task that you are asked to perform for that particular cluster. Because if you perform the task in the wrong cluster, then you will not be marked, or you will not be given the weightage of the question. Other than that, reboot is permitted, but in any of the Kubernetes exam questions or the tasks, it is not required to reboot any of the machines. So make sure you avoid it, although it is permitted. And you cannot move away from the exam browser window. You cannot be invisible in front of the camera, otherwise the exam will be stopped, and you will have to give a justification to the proctor. you must have full internet access, and make sure, or may at least try, that you don't have any firewall in between your internet connection and the machine that you are giving the exam or taking the exam on, so that you don't face any communication or the connection issues. You cannot use Control plus W in the Chrome window because it will close the window. You have to make sure that you don't use that particular shortcuts. Control C and Control V are for copy and pasting, so you cannot use the Control C and Control V in the exam terminal. You have to use Shift Control Insert or Shift Interest in the case of Windows and Linux, and in the case of Mac, you can press Command plus copy, or Command plus C, or Command plus C V to paste. Other than that, there is a notepad which is very useful. It is already present in the exam console, so you must either use the VI editor or the nano editor, whatever editor you are comfortable with in the CLI environment, or there is a notepad exam, so that if you have opened another tab and you want to copy the command and make some changes in the command, so the notepad interface in the exam portal, it will give you very good convenience in order to edit or customize your commands, rather than entering them directly and then making the changes directly on the CLI. So you can make the changes on the notepad itself, which is provided in the exam interface. Other than that, if you want to have multiple tabs of the CLI, you cannot do that, but you can use the the Tmux or screen tools which are present in the Linux, which is provided in the exam. So it is an Ubuntu environment. So Tmux or screen, which through which you can multiplex your CLIs. And you should practice the Tmux or screen, whatever you get comfortable with, and then you can use it in the exam environment as well. So objectives of the exam, let's cover the objectives in details. So starting from the cluster architecture, installation and configuration, we are going to cover in the course the role-based access control, which is related to the authentication and authorization for the users of the Kubernetes cluster, which is a very important topic from the security perspective as well. It is covered in the CKA exam as well as the new CKS exam, which is the Certified Kubernetes Security Specialist. So and the course we are going to cover in detail and perform labs of the role-based access control in the security module. Then we have an objective of using kubeadm to install a basic cluster. We have a lab for this as well. So every objective that is mentioned here, we have covered a lab in our course for all of the objectives that are going to be useful in your real life as well as in the exam. We will discuss how we can manage the highly available Kubernetes cluster and what are the options to provision a highly available Kubernetes cluster as well. Then there is an objective of provisioning underlying infrastructure to deploy a Kubernetes cluster. So this CKA course actually covers the exam, or covers the environment from an on-premises perspective. So kubeadm is actually used to install a basic cluster in an on-premises environment. So it is expected that you are provisioning the underlying infrastructure as well. Even if you are using virtual machines in the cloud, then it will be a kubeadm tool that the exam covers. Other than that, there are multiple other tools like KOps and Kube Spray, which can be used to provision infrastructure Kubernetes cluster in cloud and on-premises environment. But from the exam perspective, only kubeadm is covered. So we need to know about the underlying infrastructure wherever we are trying to deploy the Kubernetes cluster on. Then this is also important, that how you can perform a version upgrade on a Kubernetes cluster. So everybody knows that every 3 months a new version of Kubernetes is released. So it is a very frequent upgrade of the Kubernetes environment, and you must know the right procedure to upgrade the master and the worker nodes using kubeadm, or if you are using uh, any other tool, then you must know how to upgrade your Kubernetes cluster. In your managed Kubernetes environment, the cloud providers are responsible for upgrading the Kubernetes cluster master nodes, and in some scenarios they even cover the worker nodes as well. But at least as an administrator, you must know what are the steps that are required to perform an upgrade of the Kubernetes cluster. And then one of the most important aspect, that how we can backup in the case that we face some issue, or in case we are struck with a disaster. So you must understand the backup and restore procedure of the Kubernetes cluster. And we can discuss that the HCD or the etcd, which is the main database that is there for storing all of the configuration related stuff of the Kubernetes cluster. So how we can back up that particular database, and in the case of a disaster, or in the case a restore is required, then how we can actually restore that particular database, so that we can go back to our working state of the Kubernetes cluster. From the workloads and scheduling perspective, we will understand the deployments and how we can perform the rolling updates and rollbacks of our workloads or the applications that we are running in our Kubernetes cluster. What are config maps and secrets, and how they integrate with our applications, and then how we will understand how we can scale applications, whether it be manual scaling or automatic scaling, in the workloads and scheduling module. And we will try to understand the primitives used to create robust and self-healing application deployments. So Kubernetes is widely known for its best orchestration and the application deployments, and how containers and pods can be used to provision a self-healing application, and automatically scaling application. So we will cover it from that perspective as well. Then we will understand how resource limits can affect pod scheduling. So this is one of the most important aspect for a system administrator, that how you can provision enough resources and give enough leverage to your developers, so that they do not affect the whole cluster environment. So limiting your resources in order to be able to provision your workloads is very important in any production environment. And then we will discuss how actually Kubernetes applications or objects are managed using the manifests, and how you can store them in a version control system, and you can make it part of the CI/CD pipeline, and how you can automate your CI/CD pipeline. So in the services and networking, we will discuss the cluster communication between different nodes, how we can configure networking on the cluster nodes. Then there is a Kubernetes requirement of networking, which is very specific, and they ask for certain rules in order to implement networking in a Kubernetes cluster. We are going to discuss that, how the pods and containers communicate with each other, how we can use the services in order to expose our applications outside the Kubernetes cluster, how we can use ingress and ingress controllers, which is a sort of a layer 7 a proxy or a reverse proxy, how we can use that for doing our URL based routing in the Kubernetes cluster, how a Kubernetes cluster has a DNS of itself, and what it does in order to perform the DNS resolution within the Kubernetes cluster. And then we will discuss what are container network interface plugins, and what are the options to be used, like Flannel and ViewNet and Calico. So these are some examples which we are going to cover in our container and network interface plugin section, and the services and networking module. Then we have storage. So everybody is curious about running stateful workloads in the Kubernetes or the containers environment. So we will cover storage perspective, that how we can use persistent volumes in order to provision our stateful workloads, for example databases or any other workloads which has a requirement of storing data for a long-term perspective. Because as long as we are running our workloads in the Kubernetes environment in the form of pods and containers, the storage only remains as long as the life of the pod is there. So the life cycle of pod is actually, the main factor which needs to be considered when it comes to storing your data. So we have to attach external volumes to our containers or pods. We are going to cover this in the storage module. What is a persistent volume claim? How we can manually and dynamically provision storage to our pods and containers, and how we can make sure that our data remains safe even if the pods are deleted, so that we can restore from that particular data. Then there is a very useful section, troubleshooting, in which we are going to discuss the real life scenarios that we usually face during managing or operating a Kubernetes cluster. How we can see the logs of a Kubernetes cluster and the components and the services that are running in the cluster. How we can see the logs of the pods and applications that we are running. How we can monitor them, and how we can troubleshoot any cluster level failure or application level failure as a systems administrator or as a Kubernetes administrator. So these are 5 primary modules or the 5 primary objectives that are going to be covered in the course, and the course is completely aligned to cover each and every objective of the exam, as well as there are certain important scenarios that we discuss out of the exam objectives as well. So there are some real life scenarios, like how we can provision a database, how we can run Elastic Stack, how we can run a monitoring solution in a Kubernetes environment, because these are important topics for a Kubernetes administrator. So other than the exam objectives, this is also going to be covered in the course as well. So it gives you a complete, perspective from an administrative point of view, and it is going to really help you in your production environments as well. So there are some prerequisites for Kubernetes as well as the CKA exam. You must have good Linux concepts, because we are not covering the Linux part in this particular course. There has to be good enough knowledge of Linux and the command line of the Linux, so that you are comfortable, because Kubernetes is not available for Windows environments. It is only provisioned in a Linux environment. So you must have some good Linux concepts, and we assume that the candidate who is joining this particular course has at least basic knowledge of Linux command line, and he can perform basic Linux command line tasks like grep and change directory and copy and move and ls, and he must have good idea of the directory structure of the Linux environment as well. So he must know where actually the files are stored, where are the configuration files, what are kernel modules, what are the networking options for Linux machines, and how we can configure networking. So it is good to have this much knowledge of the Linux. Other than that, you should know some basic tools like grep, like output redirection, and Vim editor or the VI editor is a must in order to edit the YAML files, which are the manifests of the Kubernetes. You should know about the aliases. You should know about systemd and systemctl. You should know some basic tools like curl and wget. So it is a good handsome amount of tools that you need to have a grip on if you are going to be a Kubernetes administrator, and it is expected that everybody who is trying to learn Kubernetes, he already has a Linux background. You should also have some networking concepts like IP subnetting, and what is DNS resolution, what is a DHCP provisioning. It is good to have a good knowledge of these networking concepts. Other than that, I already covered it in the networking. You should also know what is actually DNS and how it works. So what is name resolution and how it works, like the forward zones and the reverse zones. If you have a good concept of DNS, then Kubernetes also has its own internal DNS. You will have less difficulty in covering that portion of the Kubernetes cluster and how actually DNS works in the internal cluster. Then you should have some knowledge of containers and images, because Kubernetes is the environment which is actually used to orchestrate the provisioning of containers itself. So you can run containers manually, as we will just cover that portion. Other than that, Kubernetes is actually used to orchestrate and make sure that you have a resilient cluster on which you can provision your workloads in the form of containers. And it is good if you have a basic understanding of YAML. So YAML is a sort of a data structure, or I would say that a data representation. So there are two, most famous data representation, I would say, languages or notations. Like the first one is the JSON and the other one is YAML. So YAML is more easy and human friendly. Other than that, Kubernetes supports both YAML and JSON. But in the exam, and in real life, YAML is more easier to work with. So if you have a good idea about YAML, then you will have easy time provisioning or writing the Kubernetes definition files. Otherwise, we will cover the YAML in the course as well. So that was related to the exam perspective. So before starting the Kubernetes and the course officially, since this is an introduction section, it is always better to cover some some terminologies, so that we can build a base on top of it and start with the course then. So why are containers so important? So when it comes to migrating the applications to the cloud, and we have a history of transforming our IT infrastructure from time to time. So when it came in the earlier 2000s, there was a concept of virtualization, which really changed the game of the IT industry. So that was one transformation phase that the IT that the IT industry went through. And now everybody has seen that there is another transformation going, that is migrating from on-premises data center to the clouds. So if we cover that particular scenario and your applications are running in the virtual machines, then there is an option to migrate your workloads from your existing virtual machines which are running in your data center to cloud. And there is an IaaS model, or the infrastructure as a services model. So there is a lift and shift option in which you can just migrate your existing virtual machine to the cloud, or after doing some changes, but they are not very significant changes, and it is called a lift and shift migration. So the IaaS model is one of the options when it comes to migrating the applications to the cloud. But the downside or the drawback of this model is that the VM is obviously likely to be underutilized, as it is in the case in an on-premises data center right now. And obviously VMs are the most expensive options to run in the cloud, and everybody is concerned about the cost when it comes to running applications or workloads in the cloud. So this is one of the options that people started to adopt when the cloud was in its infancy, or when the cloud was in its initial stages and people had started to move to the cloud. So this was the most popular method to move the applications to the cloud, that is running the applications in the virtual machines, and that is provided by the cloud service provider. Then there was a concept of PaaS model. So the PaaS model was somewhat more advanced than the IaaS virtual machines, because it provided you or abstracted from you the operating system layer, and provided you a platform on which you can develop and deploy your application. But this method also had its downside, that every cloud provider has its own proprietary interface for providing you the PaaS model. So either you get stuck into a vendor lock-in, or you have to redesign your application as per the PaaS model of that particular cloud provider. So this needed a lot of effort, and other than that, you also needed a lot of redesign of your application when you plan to run your application in the PaaS model. So this also presented a lot of limitations for migrating the applications to the cloud. Then came the concept of running the applications in containers. So the container, when the container technology came out back in, or I would rather say it was made easier to use for the public by the Docker company and the Docker community. Then actually it started to make sense that running applications should be so easy that if you want to port it and run it from one cloud provider to another cloud provider, there should be no change in the application itself, and the underlying infrastructure should be abstracted in such a way that it becomes easier to port the application from one environment to the other environment, whether it be an on-prem environment or whether it be a public cloud. So then it started to become more popular. The container technologies started to take over the world, and it made sense that using a virtual machine for running an application uh, has its own extra resource requirements, and which actually is not required by the containers themselves, because the containers only contain the application and the relevant libraries and the binaries which are used or which are required to run the application itself. And then other than that, there is no other the operating system dependency required in order to run the containerized application. So the containers served two or made the made the life easy in two aspects. Like for example, they are also isolated in such a way that the VMs were already providing the isolation to us, and then they also provided us lightweight. They are also lightweight, so they also provided us efficiency in terms of resources. So the IES perspective, which was providing us the isolation, and the PaaS perspective, which was providing us efficiency in terms of lightweightness, they are both covered in the containers. So if we see the Dockerized applications, they are portable and they can run in any managed Kubernetes environments or any container environment, like Azure Container Service or uh, AWS container services, or even Docker running in your own laptop. So you just have to download the image of the container, and you can run it in any Kubernetes environment or any you know cloud provider environment. So it became easier to migrate the applications, and that's what gave the boost to the containers and the container orchestrator. Because when it comes to running containers, you would always prefer to run it in the form of a cluster rather than running the containers manually, because it would become a more administrative burden if you start to run the containers manually in the environment. So, when it comes to migrating your applications from uh, existing code or existing running scenario towards microservices, or what we call a container supported, or what we can say in another way is that if we want to run them in such a way that you can properly utilize the containers in order to run your application. So there is a 3-step strategy that you have to follow. So first of all, if you have really decided that you should move your application in a containerized environment, so there is a first step that you can directly lift and shift your application from your virtual machines or whatever, wherever it is running on, towards containers. So if we have to move it to if we have to move it to containers, you can just move your existing application through Docker or whatever container building tool you are using, but the application will still be monolithic. So it will be still running in one container, but it will be the first step that you will be at least running your application from a virtual machine to the container. Then the second step is that you will start to recode your application and break your application into microservices. So microservices is a concept in which you start to modularize your application into multiple components, and these components are tightly integrated, so that makes easy for your developers to update and make changes to each of the components separately. So the microservices concept actually provides easiness to the developers, so that not the whole application upgrade is required at a particular instance of time, because it is time consuming and it is error prone, and it requires much more effort when it comes to upgrading a monolithic application. So breaking the application into microservices architecture gives you the flexibility that each component can be upgraded and has its own frequency cycle of updating that particular component, and it becomes independent of the other components. So the second step is to break your application into microservices architecture. The third step is to build cloud native applications. So the cloud native applications is an evolution of the microservices architecture, in which you are using Kubernetes and cloud related technologies which are integrated with the cloud platforms. So it makes sense to follow this three-step strategy when it comes to migrating the legacy applications into a Kubernetes or a containerized environment. Comparing containers with virtual machines, although I have briefly discussed it, but let's see it in the picturized way. So there is infrastructure in both the left and right scenarios. Then in the virtual machine scenario, in the right, we have a hypervisor layer, and on top of the hypervisor, we have virtual machines running. So each virtual machine is having its own operating system. That means that each virtual machine will have its own kernel and will have its own hardware that is dedicated to that particular virtual machine, and it will consume the resources of the operating system as well. And on top of that particular operating system, the application is running. Whereas on the left side, there is a host operating system, and then there is a container engine, which is actually responsible for running the containers and making sure that the containers are isolated and provided the resources that they are required. So the hypervisor layer is not required anymore in order to run the applications in containers, although you can run the operating system on which you are trying to run the container engine on a virtual machine. So if you have a virtual machine, then you can install a container engine on top of that virtual machine, and then you can run multiple containers. And containers are so lightweight that the factor that we used to cover in the virtual machine scenario, that one application has to be run in a single virtual machine, that is factored out in the case of containerized applications, so that a single host operating system can run hundreds of containers without even disturbing other containers, because the isolation is provided through the namespaces, and the resources are controlled through the C groups or the control groups. So these two particular features of Linux, which are the namespaces and the control groups, which have been there in Linux since early 2000s. So these are really used to run containerized application in a single host, which provides you the best isolation and the control over your resources in the operating system. So covering some of the containers terminology will provide you or give you easy understanding of the containers, and eventually you will have more easy access to the Kubernetes environment. So starting with the container image. So a container image is just a bunch of files which are stored in either a container registry or in your own laptop, or in a system on which the container engine is running. So container image is a file which is pulled down from a registry server and used locally when starting containers. So it is composed of multiple layers. a container image. So each layer has its role that plays a part in the formation of the container image. So if you are a developer and you have to build a container image, then you write some commands, and you as a result of those commands, an output is generated in the form of container image, and there is a metadata which is associated with that particular container image. So in that, the details like which architecture the container image is supporting, and what are the kernel requirements of the container image, and which platform it can run on. So these details are present in the metadata of the container image, and that particular container image is then used to run containers which are actually running in the memory of the operating system. So the container image is standardized in the way that there is a container image format. So before this was standardized, Docker was the most popular platform, or the engine, or the company which started to provide the container images in a particular format, and then everybody joined forces in order to make it a standard, so that all the container images that are developed uh, are standardized by using the Open Container Initiative. So the container image format is called an OCI image format, and all of the container engines which are present right now, like Docker or Rocket or Cryo or Containerd, all of them support this particular OCI image format, so that it becomes easier for developers to develop images in such a way that there is no particular requirement of a container image to be run in a particular or a specific container engine. So this is now standardized, and it has actually made lives easier for the developers to develop the container images. So this defines the layers and metadata within a container image. So within a certain set of rules, this container image has to be developed, and in order to be run by using any of the container engines. Then the container engine itself is a piece of software that accepts or provides instructions to run the containers in the operating system or the host on which you have installed the container engines. So this is the main actually application, or sort of, you can correlate the container engine with the hypervisor of the virtual machine, but it is not exactly the same thing. But it is actually used to run the containers by using the container images that are present in the host. So there are some popular container engines. Docker is one of the most popular container engine right now, but other container engines which are supported with Kubernetes are also there, like Cryo and Containerd. Other than that, there was a container engine, or I would say there is a container engine with the name of Rocket, and the native Linux container engines, which are called the LXD daemon and the LXC or /LXD. These terms are used with each other, and the native container engines are also present. But the most popular one is Docker, and now Cryo is gaining the market as well. Many cloud providers like Azure and AWS, they run actually their platform as a services or serverless services using containers, and at the back end, and they have their own container engines as well. Like previously, Azure introduced the Azure Container Service with the name of Azure ACS, and AWS also had its container service, and then they also introduced the EKS in the form of Elastic Kubernetes Services and Azure Kubernetes Services. They all support OCI compliant container images, and they are also using container engines, one of the container engines that I mentioned, at their backend. So having an industry standard container image format allows interoperability between all of these platforms. So, the last terminology that I discussed, just because of that, you can run your containers, whether it be in AWS or whether it be on Azure. So this is the real portability that, the industry was looking for, that if you want to run one application and your one cloud provider, for example Azure, and then you have to move it other cloud provider just because of some reasons or the company requirements, then you can move it because the container images have become a standard, and it is providing you the portability that you were looking for, along with the cost savings that you are not getting in the case of virtual machines. So moving virtual machines from one cloud provider to another cloud provider is also possible, but the issue is that it is always going to be difference in the cost, and obviously VMs are the most expensive option in the cloud providers. So in the case of containers, you get some savings because you can consolidate more and in a better way, and you require less number of hosts running your applications in any cloud provider. So it is definitely going to be easier when migrating your applications from one cloud provider to another, and in the terms of costs as well. So we have a question from Ahmed Bilal. For study, can we use multiple container engines in VMware Lab? Yes, definitely. You can use multiple container engines, but for Kubernetes, it is always going to be, one container engine or one container runtime interface that you configure when you configure a Kubernetes cluster. So you can have multiple container engines running in your operating system, but when selecting a particular container engine for Kubernetes, it is always going to be one, because Kubernetes cannot run, the containers on using multiple container engines. So when you initially configure the Kubernetes cluster, you tell it that which of the container engines that the Kubernetes should use, and once it is configured, then Kubernetes will start using that. And if you want to switch from one container engine to another, you can always do it, but obviously it will require some downtime, and the containers which were running previously on the other container engine, those will be disappeared, or you will have to delete them from the Kubernetes environment, because Kubernetes only supports running one container engine at a time. So the container itself is, the runtime instantiation of a container image. So the container image, I would say that it is only a file that is present in your disk in the form of layers. But the container is actually the runtime, or the application that is running in the memory of the operating system. So it is just like a process that is running in your environment, and it provides you the application interface using which your users can access, or whatever purpose that particular container is used to serve, or made to serve. Then the container is actually the instance that is providing you the services. It runs in its own namespace, and it is isolated to the control group, the two terminologies which I mentioned before. So the namespaces of Linux, it is a concept that that has been there for a long time, and the containers also use this concept. So in an operating system, or in a Linux operating system, you use multiple namespaces for each container, so that each container sees itself as running or controlling the whole operating system. So it provides you the isolation, and the resources are controlled through the control groups feature uh, of the Linux kernel. So these two Linux kernel technologies are used to run containers, and when these are used, each container has its own host name and IP address, and can have its own disk as well. So this is and also the host, also the UTC. So there are some namespaces which are shared between containers, and there are some namespaces which are completely isolated, so that it sees itself as a completely isolated running application. Then the container host itself is the system that runs the container. It can be a bare metal machine, it can be a virtual machine, it can be an instance in a public cloud that you can use to run the containers. And once a container image is pulled from a registry server to the local container host, it is set to be in the local cache. So each host which is a part of the Kubernetes cluster, or a Docker Compose cluster, or a Docker Swarm, So, each host acts as a local cache. So every host either has to be, pointing towards a public registry from which it can download the container image, or you can provide your own private registry space as well, using which you can, download the container images and eventually run the containers in the hosts. So you can run multiple containers on a single host as well. So this is one example, that you have a computer and an operating system. It can be your laptop on which you have installed Linux, uh, or a supported operating system which can actually run the container engine. So Docker here in the case is running, and it can run multiple containers. So container one will have its own host name and IP address and disk. Container two will also have its own host name, IP address and disks. And the operating system itself, will have the details just like any other system has. So these three, I would rather start my pointer. So these three will have its own host names and IP addresses. So these IP addresses of the containers will be able to talk to each other using the container network interface plugins, and then the host will also be able to talk to these two containers just by using the same container network interface plugin as well. So every host has access to all of the containers, and the containers can talk to each other as well freely when you have completely configured a Kubernetes cluster. Then the registry server is just sort of a repository on which in which all of the container images are present, and you can use that particular registry to download the container images, or in the right terminology, you can push and pull the container images to a particular registry to store your container repositories. So the registry is specified as a normal DNS name, and optionally a port number if you have deployed it in a non-standard way. Otherwise, usually it is hosted through your usual HTTP and HTTPS protocols, and you can push and pull container images from the registry servers. And the registry servers can be public or private. So the public images are also present, and you can also build your own private registry. So if you have a team of developers who are developing container images, then you will have to provide them a container registry so that they can push the image to the container registry, and when it comes to running your containers, the host will be able to pull it, or pull the container images from that particular registry. Container orchestration. So whatever we have discussed up till now was related to the manual running of the containers. So let's just sort down the steps that is required to run a container. So manually you install a container engine on the host, and then pull container images, or either build new images, and pushing them to registry and share. Then in order to run the containers, you either run a Docker container run command or a Docker run command. And if you want to run multiple containers, then you will have to run the same command again and again for multiple containers. And if you want to connect the containers together, you will have to define specifically that which containers want to communicate to the other containers. So it is all a manual process. So what a container orchestration do is that it does the following tasks: that it dynamically schedules the container workloads within a cluster of components, within a cluster of hosts or a computers. So in the case of running containers manually, you cannot scale the application very efficiently, because you will have to make a cluster, and then you will have to make sure that you spread the workloads or the applications on the on the on the on the multiple number of nodes that you are planning to provision on. What the orchestrator does, whether it be a Docker Swarm or Kubernetes, it dynamically schedules the container workloads within the cluster of hosts that you have provisioned, and it also provides a standardized application definition file. So in the case of container engines, every container engine may have different method of running the applications in the form of clusters. So Kubernetes has standardized the application definition file, and provided you the benefits of the orchestration. Other than that, the orchestration, it also provides other capabilities like it, allows containers within application to be scheduled completely separately. So every application has its own environment, and it can have multiple containers, and it's completely isolated from other applications. It also allows the utilization of large clusters of container hosts. So if you want to build a large Kubernetes cluster, then you don't have to worry yourself that which nodes are underutilized and overutilized, because the Kubernetes scheduler efficiently schedules all the containers among all the hosts present in the cluster in the most efficient way. If the individual containers fail, the orchestrator is responsible for restarting that particular container. The In the case of running a container engine manually or running a container manually, this won't be possible. Other than that, if the cluster hosts fail, then it provides you the high availability, because the cluster has to is really formed to provide high availability. So if the container engines fail also, the containers that are running in a particular host, they can be rescheduled onto a different host when there is a cluster and there is an orchestrator running behind the cluster. If you want to scale up or scale out your application, or scale down with respect to the traffic that you are getting in your application, then orchestrator can help you with manually scaling and automatically scaling the application as well. So it really gives you the harmony and the orchestration feature. When it comes to Kubernetes, it really gives you the flexibility in provisioning your applications in the form of containers. So coming towards Docker, Docker is a tool as well as an engine. It is a tool for creating and managing container images. So this is one of the tasks of Dockers, that you can build in new images. You can push images, you can pull images from container registries using the Docker CLI, and the Docker itself is also container engine as well. So Docker, the Docker binary or the Docker tool has multiple purposes that it serves using the single binary. Or you would say it is Docker itself is a sort of a monolithic tool that is provided, and it has been running there for 7 years now, and it has been the most popular container engine and the tool for creating and managing container images. So there is a demo of Docker installation. So I have a virtual machine running in my environment. So let me just zoom a little bit so that you can see it in a better way. Okay, so I don't have the commands present with me right now, because whenever it comes to installing Docker, so I use the official guide, and let's follow the guide again, so that you also get the idea that how we can install Docker in our laptop or any virtual machine, because this is one of the container runtimes that is required to run a Kubernetes cluster. And if we go to the Kubernetes documentation, it will also ask us to install one of the container engines. So there are three supported container engines, out of which one of them is now deprecated, which is I believe Docker. So if we have to run a container runtime, there are still three listed on the Kubernetes documentation. The first one is containerd, the other one is cryo, and the third is Docker. But the Docker support is now getting deprecated, and it will be just another 1 year, that will be 2021, in which Docker will be supported up to 1.22 version of Kubernetes. After that, the Docker container engine, only the container engine part of Docker will not be supported by Kubernetes. And then you will have the option of containerd and cryo. So just because the support has been deprecated just now, we cannot completely skip the Docker part, because Docker has been serving us for so many years. So it is always good to understand the technology itself. So I decided to cover it. So I have already run the update on my machine, So I will just copy this second command, which is installing some prerequisites for running Docker. And let me just give it the sudo password and start to download the prerequisites. So once the prerequisites will be downloaded, I will be adding the official Docker GPG key so that I don't get the particular error of the hash. So once it is added, I don't need to verify it. I will add the repository of Docker so that it can download the Docker from the repository. So once the repository has been added for Ubuntu, so just to tell you that I am running Ubuntu 20.04 in my virtual machine. And then after doing the update, I will install Docker CLI. Okay, so by the way, since this is an introduction class, I'm giving you the demo. Other than that, in the course, when you will join the course, you will be, doing this in the lab. So you will, get a hands-on of installing the container runtime engine, and you will also provision a Kubernetes cluster yourself as well. So I've just copied, 3 to 4 commands from the official Docker installation documentation. And once this is completed, we can start to, play with containers and do all kinds of stuff like pushing and pulling the images and running the containers. So it is almost done now installing. Coming back to the slides, the installation demo. Okay, so while it is installing, let me just explain you a little bit of background working of Docker. So this Docker which we have installed is, it provides you two things. One is the server, which is called the container engine, and one is the client, which is the Docker CLI. So when we try to run Docker command, it is actually the Docker CLI, and then it talks to the Docker engine, which is the server portion of the tool, and it tries to fetch whatever information you are asking or whatever task you are asking to perform using the Docker CLI. So once Docker is installed, let me just see the status of Docker using the systemctl. So we can see that the Docker is running, and if I just type Docker, it will give me all the commands. So this is the Docker CLI, and if I do Docker version, I did a spelling mistake. So if I do a Docker version, then it will give me the client details, which is this, and the server details as well. So the client is also 20.10.2, and the server is also 20.10.2. So these are the two components which are really installed when you install the Docker in your host. So, whenever you run the Docker command, it, talks to the Docker API, and the API eventually is exposed by the Docker engine. And the Docker engine also, as I told you, that there is a local cache for every host. So if I run this particular command, let me show you. So if I run a particular command to run a container, so let me run Docker container run hello world. Okay, so what it is doing is that it saw that there is no such image with the name of hello world latest locally. So it is now downloading the image from the official Docker hub. So if I go to Docker hub, let's explore Docker hub. So Docker Hub is a public, or if you have an account, it is a private container registry in which you can host your particular container images. So if I come to the hello world image, which I have just run in my own environment, so this is the hello world image name, and I could either use Docker pull to download the image, or I could use Docker container run in the way that I did, Docker container run hello world. So what it did is that since it was not present in my system, it downloaded it initially and then it ran automatically. So this particular container is only meant to provide us this particular output. But now if I run the same command again, so the first step will be skipped. So you see that if I ran the same command again, it has not downloaded just like the first time. So initially it was not present, but now it is present, and we can verify it using docker image ls command. So I can see that in my local cache there is a container image with the tag of latest, which is now present in my system, and I can use it to run the containers as well. So if I run another container, for example, docker run Ubuntu. So although it will take some time to download the image, but it will follow the same process. Like for example, it is not present in my system, so it will start to pull the image. And as I told you that there are multiple layers which compose the image, so it has started to download the multiple layers of the image. And now it is extracting the image so that it can be used to run my container. So it is as you can see that Ubuntu was run, and it completely ran and exited, because Ubuntu container image does not have any process that keeps on running. So it just ran and exited. So if I show you that what are the running containers, so right now there are no running containers. But if I show you the exited containers as well, so there are 2 or 3 containers which ran and exited. So if we see the status, then the Ubuntu container actually ran. It ran the command bin bash and exited. So if I run the same command with with the 2 flags, which is I for interactive and T for TTY. So what will happen is that it will give me a session of that particular container. So if I run this command like this, so I am now in the container itself. So you can see that my prompt has changed from arrow to root at the rate of some values. So if I do a host name, so this is actually a container, and I have taken the bash prompt of that particular container, and now I am running Ubuntu in a container environment. So this is how using this particular command which I just ran, docker run -it, that means interactive and TTY terminal of the image Ubuntu. So this is how you can enter into a container environment. So if you want to exit, and if I will exit it, so in the case, let me just clone this session and let me show you from the command docker ps. So there will be one container running. So this one container is now running, and we can see it that its status is up from 52 seconds, and the command that the container is actually running. So if I exit from this particular bash terminal or the bash shell prompt, then what will happen is that the running container will also exit. So if I run the same command in the parallel session, so you will see that the container has exited. So if I do docker ps -a, it will show me that there is one container that just exited, about 10 seconds ago. So there are 4 containers that I have run up till now, and 2 of them were hello world and 2 of them were Ubuntu. But for the hello world, it just displayed the output twice. This was the first one and this was the second one. And for the Ubuntu, it ran bin bash. The first time there was no attachment with the shell, so it ran and exited. The second time I attached it with the shell, so it ran and did not exit. So by default, the containers are run to are meant to run the container. The containers are meant to run the applications in such a way that they keep on running. So if I want to run a website using Nginx application, so what I will do is that I will use the D flag, which is used to detach the container from the currently running interactive shell so that it keeps running on the background. And if I want to publish, then what I will do is that I will just write the host port and the container port. So what it will do is that it will provision an nginx container, and it will publish the port or provide the port mapping from the container to the host, so that if we run a particular if we want to run a particular website, you can use it, you can browse through it using this particular port. So when I will run the container of nginx, it will first download the nginx image, and once it is downloaded, it will run this particular container in the background. So we will see that the nginx server will be running in a container, and when we will do a docker ps, we will see that it will keep on running, although we will also have our host shell present with us. So it is now extracting the image, and once it is extracted, the prompt will be returned back. So I believe that I have just changed. Okay, so what it is doing, that it is saying that entry point is not found. Okay, so there is some change. Let me just type the name after. And now we see that the container is running. So if I do docker ps, so we see that there is an nginx container running. So let's run another nginx container and just provide it the right port, and let's give it the name as well this time. So if you see that first time when we ran it, there was a name which was a random name, but now this time, since we have provided a name itself, so it is now running as nginx. So if I go to my browser, and let me just show you the IP address of this particular virtual machine that I'm running on. So if I just copy this and go to my browser and run it with the port 8080, I should see an nginx web page, which is the case in this scenario right now. So this nginx server is running in the container rather than running on my particular host. So if I show you this particular nginx running, and I show you the process of of this particular container. So there are two processes running in this container, which is the master, which is the command nginx, and which is the master process of this particular container. So I just did a docker top nginx, and it showed me the processes running in this particular container. And if I want to attach my interface, or attach my shell to this particular container, then I will run docker exec -it command using the name of the container. So then it will give me the exec or the shell interface to this particular container. So I believe the docker exec -it option container, and it wants me to give the command. So if I want to run bin sh, then right now in the nginx image, the bin sh so shell is not present. So what we can do is that, okay, so now we are in the nginx container. So the host name of this particular container, as we can verify it from here, and if I do the docker, I think it's some else. So if I do a docker ps, then this is the container ID, and it is giving us the same host name as we are into the shell of the container as well. So I am in the container, and if I do the ps, so the ps is not present. So if you see that the nginx image only has the relevant binaries, and there are no other binaries which are usually present in the Linux operating system. So a container is a very lightweight application, and using this particular container image, we are only able to run the Nginx server. So, all the irrelevant binaries have been, factored out from this container image. So if I come back to the slides, I have just shown you the demo of these particular commands that that I have mentioned in the slide deck. So I believe this you can just have a look at this at these commands which are available on the internet as well, and you can try it yourself and start to run a container by using these predefined or the already published container images. And the container lifecycle, I've just shown you the container lifecycle that containers only run while the application is running. So as soon as the application process which was meant to run in the container it exits, then the container itself also exits. So this is just one example that how you can connect to the container. So I used two flags, which was the interactive, or in the short form I, and T, which is the short form of TTY. So this is how you can connect to the shell of the container. And then if I also showed you that how you can detach a container and publish the port of the container. So this was all manual tasks, and it is only limited to running in your own host on which the Docker command line is running. So if you want to run it in a remote host, then you have to do other configurations, and you have to make sure that the containers run in other hosts as well. So all of these manual tasks that I have just performed, they can be I would say automated by using the Kubernetes engine, which is the orchestration. So you just have to write a definition file, and using that definition file, the containers will run by themselves and on a particular host, which is going to be decided by the scheduler that is running in the Kubernetes cluster. So I believe communication I have also showed. So each container will have its own IP address, but that IP address, will be, within the Docker environment. So it will the IP addresses will not be accessible from the physical network. So you have to do a port mapping just like I did. And if you want to expose your application, you have to find some other means to expose the application running in the container environment. So Kubernetes gives you the flexibility of exposing the applications in terms of services as well. And it makes it easier to expose the application which is running in the Kubernetes cluster. So I believe that is it from my side that we are going to cover in this session. So this is just another way of doing the container communication. So what I did is that I exposed the port 8088, and the container itself was running the application on port 80 with the separate IP address, which is totally inaccessible from the outside world. So if anybody who wants to connect to this particular container, so since this container is published on port 8088 using the IP address and the combination of the port of the host on which the container is running, we can access the container application, container application, or whatever is running inside the container. So you have to publish it using a port, or you will have to make sure that the container is exposed in a particular way. And using Kubernetes services, you can expose your applications. And there are 3 types of services which we are going to cover in the course. And we will discuss in details how we expose our applications which are running in the Kubernetes cluster in the form of containers or pods to the outside world. So I believe, okay, so there are some troubleshooting commands of Docker as well. So I just showed you one of the command. So let's see Docker logs as well. Let me just go back to my shell, and let me show you the logs of Nginx. So, I tried to access the page using my host. So there is an entry that there was a page request get, and then it returned some errors as well. So all of the logs you can see using the Docker logs of that particular container. Then there is a Docker container inspect and Docker container stats. So Docker container stats Unix. So it will, okay, so there was a typo. So Docker container stats will show you the memory utilization and CPU utilization of the container itself, and the network IO and the block IO. And then if I go to the Docker container inspect Nginx, it will show you the details of the container in the JSON format. So these are some troubleshooting commands in which you can find out about the container, find out the details of the containers, and the IP address that the container gets, the gateway of the container, the ports which are used to expose the container, and the other details like the volume mounts, if there are any volume mounts related to the container. So these are some troubleshooting commands that are provided by the Docker CLI. So that is it from my side. Waqas bhai, if you are there, you can discuss the other aspects of the training and the course. And I hope this was a fruitful session, and you guys at least got some idea of the Kubernetes and the CKA exam, and some a quick walkthrough of the Docker itself. So over to you, Waqas bhai.
Thank you, Usman bhai. Uh, if anybody has questions right now, trainer is with us. They can ask. And hello.
Do anybody have any questions, please? You can write to us as well in the chat box.